Hey everyone. So let's talk about something that honestly sounds like it's been ripped straight out of a science fiction novel, but it's actually happening right now. We're talking about taking our data centers, our servers, pretty much our entire internet, and just putting it all in the sky. It's the wild world of aerial computing, and it all kicks off with one simple, kind of scary question.
Just think about it for a second. What if you woke up tomorrow and the internet was just gone? No connection, no texts, no GPS, absolutely nothing. It's a pretty terrifying thought, right? Well, for a lot of people in certain situations, it's not just a thought experiment.
Because, when a natural disaster hits, an earthquake or hurricane, a massive flood, all that infrastructure we rely on, it is incredibly fragile. Cables get cut, cell towers get knocked over, power grids fail. And in those critical first moments, communication, the one thing you need to coordinate any kind of help, is the very first thing to disappear.
Okay, so if the ground itself is the weak point, what's the solution? Well, it's kind of simple. You just leave the ground behind. You build a network that can't be knocked down because, hey, it was never on the ground to begin with. This is the whole big idea behind computing in the sky.
So what are we actually talking about here? I want you to imagine taking all the guts of the internet, the servers, the processors, the routers, and just strapping them to things that fly. It's a whole system where drones, these massive balloons in the stratosphere, and satellites all become little nodes in one gigantic, dynamic, airborne network. And look, I have to make this super clear. This isn't some dream for the year 2050. As our source material puts it, and this is a direct quote, this is not science fiction anymore, it's being tested right now. Companies, research labs, they are actively building and flying these things as we speak. All right, so how in the world do you actually build an internet in the sky? Well, it works by thinking in layers. The whole system is designed with this three-tiered architecture that creates an incredibly tough and flexible network right in our atmosphere. Each of these layers has a really specific job, kind of like a well-coordinated team. You've got your low-flying drones for quick local jobs. Then you've got these high-altitude platforms for bigger regional coverage. And then way up top, you have the satellites providing that global backbone. Let's start from the bottom up with the drones. So think of these drones as the first responders of the sky. They're flying below 1 kilometer, and they are the rapid response team. In a disaster zone where every single cell tower is down, you can send in a whole fleet of these things to create an instant pop-up communication network. They literally act as mini flying base stations for everyone on the ground. Okay, next up, we're going to move way up into the stratosphere to layer 2, the high-altitude platforms, or HAPS. Now, these are things like massive solar-powered airplanes or giant balloons, like the ones from Google's old Project Loon. These things can stay up there for weeks, even months at a time, beaming internet down over an area the size of a big city. They're the crucial link between the drones below and the satellites way above. And finally, the top layer is what ties everything together. This is the system's global backbone, constellations of low Earth orbit, or LEO, satellites. You've probably heard of things like SpaceX's Starlink. These swarms of satellites are what give the entire network its planet-wide reach, making sure that data can get from a drone over a rescue site all the way to a command center on the other side of the planet. Now, here's the really important part. These layers don't just work by themselves in a vacuum. They form what's called a sky-to-cloud continuum. So the drones and HAPS can do quick calculations right there in the air, that's what we call edge computing, but they can also seamlessly connect to powerful cloud servers back on the ground for the really heavy-duty processing. It's really the best of both worlds. I mean, this is all fascinating technology, for sure, but why does it really matter? What actual problems can this solve? This is where aerial computing goes from just being a cool idea to something that could genuinely change the world. Let's just start with this one number, 2.7 billion. That's how many people around the world still don't have internet access today. Building out ground infrastructure to reach every single one of them is insanely expensive and would take forever. An aerial network, well, that offers a real shot at finally closing that digital divide. And this is where the advantages really start to stack up. Because the whole network is mobile, you get this incredible flexibility to put it wherever you need it, whenever you need it. Because it's in the sky, you get truly global coverage, and it's so much more resilient. I mean, an earthquake can't exactly shake a network that's floating 20 kilometers above it. And if you need more bandwidth, you don't build a whole new tower, you just launch another node. Let's paint a picture of how this all works together in a real-world job, like smart farming. So you'd have drones flying low, grabbing super detailed, real-time images of the crops. That data gets instantly beamed up to a HAP, which uses its onboard AI to analyze plant health right on the spot. And all the while, satellites are giving you that big picture view with weather patterns and soil data. It's perfect teamwork, all happening in the sky.
And honestly, the possibilities here are pretty much endless. We're talking everything from life or death missions like disaster relief and secure military operations, all the way to commercial stuff like connecting remote sensors on oil rigs or creating instant 5G hotspots for a massive concert. You could even bring high-speed internet to the most remote, beautiful tourist spots on Earth.
Of course, it's not all easy. Building a data center in the sky, as you can probably imagine, comes with a whole host of challenges. There are some really significant technical and logistical hurdles that engineers are working like crazy to solve right now. I mean, they're tackling some huge questions. For example, energy. How do you keep thousands of drones charged while they're flying? In orchestration, how do you manage a network where all the nodes are constantly moving without it just becoming total chaos? And then you have the really practical stuff, like regulations and cost. Clearing the airspace and making this stuff affordable enough to actually use at scale. So after looking at the tech, the applications, and all the challenges, what's the big takeaway here? Where's all of this really heading? It really boils down to this. Aerial computing isn't just some neat add-on to the internet we already have. It represents the next fundamental evolution of the cloud itself. We're literally watching a shift from a system that is purely on the ground to a hybrid one, where data and connectivity live both on the Earth and in the skies right above us. And this just perfectly captures the ultimate vision. I'm going to leave you with this final thought from the source material. The future of the cloud might not be on Earth at all. It may be above us, floating in the skies. So the next time you look up, just remember,